Good morning, good afternoon, good night, wherever you are. I hope you are safe. We're going to just go ahead and jump in. Today's lesson is very aligned with your Delta Math assignment that is due on Tuesday, March 31st. So the three sections that you're responsible for on Delta Math are called the exact value of trig functions, 2, evaluate basic trig functions, and 3, the exact value of trig functions, part 2. So the first one is just basic trig functions using the unit circle. We're looking at degrees. The second one is really basic radians values. And the third one is the more complex radians values that can be found in these three quadrants as well. So the things you need to know more than anything is unit circle, unit circle, unit circle. You need to know how your coordinates align with your trig functions, and then also your reciprocal functions. When I say unit circle, I also do mean unit circle in radians and in degrees, because you will be asked for both. This is no calculator needed. So the first thing you are going to do, of course, is set up your unit circle, because if you set up your unit circle from memory, then you will be fully set up for success when it comes down to actually solving some of these problems. So I'm going to go ahead and make my unit circle, meet you back. I'm going to actually go ahead and pause this video. You're going to create your own unit circle and then check back in with me. All right, your unit circle should look something like this. Notice I have degrees, I have radians, and I have my coordinate points in some kind of organized way. And maybe color coding. If not, that's okay too. All right, so we've got our unit circle set up. Now let's go ahead and think about our coordinate points. Remember, your x coordinate point is always your cosine, and your y coordinate point is always your sine. So if you're asked for cosine or sine, you're just going to look at the coordinate points and look for the corresponding one, right? So then we don't want just cosine and sine. We also do need to know tangent. So you have to remember that if you're looking for tangent, it's not one of the coordinate points. It's actually the idea that tangent is sine over cosine. So then you look at your coordinate points when it's asking for tangent, and you are going to plug in exactly what you need. Okay. Last but not least, we have to think about our reciprocal function as well. Now let's go ahead and jump into some practice problems. All right, guys, so we've got a couple of practice problems here that all align once again with the three topics of our first Delta Math assignment for this quarter, the trig review number 1. So the first one aligns with your first types of assignments, which is called finding the exact value of trig functions. So these two is what we're going to start with using the unit circle that I created earlier and some of this extra review information we have as well. So let's start with sine of 330 degrees. So the first thing you want to do is look at the unit circle you created and identify exactly where 330 degrees is. Bam, did it, right? Then you want to find sine. So take a minute, think back, which value, right, your x or your y value will sine of 330 degrees be? All right, yeah, you should have gotten your y value. Therefore, your value for sine of 330 degrees is just -1/2, right? So that one you don't really need to show work other than the fact that your whole unit circle is set up from memory. Now let's do tangent of 90 degrees. So tangent is that one, right? It's not in either of your coordinate points, so you have to put sine over cosine. So first, let's locate 90 degrees, right? You should do it before I do. I'm going to go slow, and we are at 90 degrees. So we have cosine and sine, right? So to find tangent, if we have that 90 degrees is 0, 1, or cosine is 0 and sine is 1, you want to put sine over cosine, meaning you are going to put your y value over your x, right? You put your y value over your x or you just put 1 over 0. So your answer is 1 over 0. But any number divided by 0, right, anything divided by 0 is undefined. So your answer is actually undefined. That is your final answer. All right, now let's go to radians, right? Same drill. You want to identify the angle measure, identify what function it's looking for, and that's how you'll find your answer. So these two are actually both looking at pi over 6. So pi over 6 is in your first quadrant, right here. So if it's asking for cosine of pi over 6, we're looking for the x value. So your answer will be root 3 over 2, right? Next question, so part 2 of question number 2 is asking for tangent. Tangent, once again, is sine over cosine. In other words, y over x. So we want to look at what our y and our x values are. So in this case, we have 1/2 over root 3 over 2. And so then you have a mega fraction, right? Mega fraction. We don't like that, right? I'm still here, and I still don't like mega fractions. So in order to divide a fraction, remember you multiply the numerator by the reciprocal of the denominator. Reciprocal just means a flipped fraction. So you get your numerator, that stays the same, 1/2, and you multiply it by this flipped fraction right here, 2 over root 3. And so once you do that, your 2's cancel out and you get 1 over root 3. No, still a sad Miss Abdi. Think about all those presentations we did right before we let out about rationalizing the denominator. So in order to rationalize the denominator, I'm going to bring that 1 over root 3 down here so it's super clear. You're going to multiply by root 3 over root 3 in order to cancel it out. So when you multiply fractions, you multiply it exactly across. You get root 3 over root 9, which is the same thing as root 3 over 3. Yep. So that is how you do the basic radians common angles problems. Now the third one is going to ask you for some more complex, not in the first quadrant angles, such as 7 pi over 6, and then it's also going to start using reciprocal functions as well. So let's start with 7 pi over 6. We're looking for sine of 7 pi over 6. So you'll see, right, remember how this is our regular quadrant, -1 for radians, +1 for radians in the numerator, and times 2 minus 1, right? That's still a thing. So 7 pi over 6 is in the third quadrant, our +1 quadrant. So we're looking for our cosine and sine, but it's actually asking for sine, right? Our question is asking for sine, so our sine value will be -1/2, or our y coordinate. So the answer is simply -1/2. All right. Now, secant of 5 pi over 3. So you're going to identify your angle measure. 5 pi over 3 is in the fourth quadrant right here. We've got 1/2 and we've got -root 3 over 2. Now we're looking for secant. So you want to remember for your reciprocal trig function, secant is 1 over cosine. So you want to identify, first of all, cosine of 5 pi over 3, then flip the fraction to get secant. So cosine of 5 pi over 3 is the x value, right? So let's just go ahead and write that we know cosine of 5 pi over 3 is 1/2, right? But we don't want cosine, we want secant. So we want to find what 1 over cosine would be. Therefore, we're looking for the reciprocal. Like I said earlier, reciprocal is just a flipped fraction. So it's 2 over 1. In other words, just 2. That is what secant of 5 pi over 3 is. So you're still going to identify the angle measure, identify the function it's looking for, and then confirm it. That's all. Use this to help you answer the Delta math, and let me know if you have any questions. Bye. One final note is I want you to pay attention to how I'm showing work on these problems. It might seem like there's really no way to show your work on every single unit circle problem. I will say these ones, you really don't need to show your work, but there are opportunities for you to show your understanding here. It's a way for you to protect yourself and to prove your knowledge.